Hi Engineering Science, Mr. Young back again here just for a quick video for an example on tension and compression. I mentioned it on one of the previous structures videos about different types of forces. I just wanted to cover these two because they can act together in some ways on structures. And we'll have a wee quick brief example. So you may have an example like this, so I'll hang in basket. And we're actually going to look at the bracket. So if we look side on at the bracket here, I've got a wee drawing on it, but we'll get a wee bit of a pen here. So if we look from this kind of direction, I'll have a wee kind of drawing that should look like that. So this bit here is your wall, and then you can see the triangle for the hanging basket. There should be a line here, maybe a blue line to show the bracket being attached to the wall. I've missed it out, but you can see that the other bits are here, and that would be down there as well. Now this bit here is your hanging basket, and also what it is, it's the weight of the basket. Okay, remember what we said about weight? Weight is a force, so it's the force acting down on this as well. Okay, so weight is a force, and you can calculate that out by doing mass times gravity. So we know that the masses of this in kilograms, times it by the gravity, we can work out its weight. We don't really need to do that just now. What we're looking at is how this weight is acting on the two members. So every part of a structure here is called a member. So this top one here is member A along the top, and the one diagonally down here towards the wall is this one here is member B. Okay, and what we're looking at, when we look at member A, this is getting pulled down, so this is actually getting kind of pulled this way a little bit. I know it's stronger than it seems, but it's getting pulled. So when you're pulling something from both ends, and it's obviously secure at the wall, so when it's getting pulled, that means it's under tension. So we've got this kind of effect going on here. It's getting sort of pulled away. Now that's under tension, like I showed in the last video. So tension, when we talk about things under tension, we say it's a tie. And I always just remember it just saying it's try to keep the rest of that bracket tied to the wall. So it's like it's tying the structure together. That's the way I remember it. So tension, tie. So when we're looking at member B now, you can see this here. This is getting pulled down again. The weight of the basket is pulling down this structure here. So when this is pulling down, this is actually kind of going in the way here. And it's getting squeezed by the wall as well because it's got nowhere else to go. So this is more likely to be under compression. So we look at this action of this, it should be like this. So it should be kind of getting, this weight is getting pulled down, it's getting pulled in at this end, and the wall, the reaction force from the wall is kind of squeezing in this bottom member. So we're going to say that's a compression. All right, it's being compressed, and when things are being compressed, they're called a strut. Okay, and that is it. That was all I wanted to show, the difference between tie and strut for tension and compression. Okay, so you just have to kind of bear that in mind when you're looking at structures and you're looking at the force acting on the structure. What is it doing? Is the member being pulled, or is it being kind of squashed? And that's all we're kind of looking at there. It's nothing fancy or anything. It's just those two, and that's it. So I'm off. Stay safe, and thanks. Bye.